All right, so yesterday, I think we finished up with example 3A. We talked about this first one, so we should be on example 3, and you probably wrote it down yesterday, but when the negative is outside, and we're going to make this a little simpler today too, okay, with how we write stuff. We're not going to distribute it all the way out or anything like that, because in your calculator, when you go to find the new graph, you can just put the negative in front of everything. But if you look on this one, that negative is in front of the f of x. So what that makes for us, and we wrote this down yesterday, is an x-axis reflection. And you should be referring back. You can be referring back and forth to that chart on the front page, right? Those negatives, I think that was the last thing down there. The negative outside was x-axis reflection. Negative inside was y-axis reflection. Okay? But this one's a negative outside. And if you remember yesterday, I drew the picture, or I tried to as best I could. And again, it's just a sketch. So if you're looking at your paper with the graphs, this is example 3. Remember, we took everything from the top and we tried to bring it down to the bottom as best we can, guys. Okay? It doesn't have to be perfect. But all of this hump right here is on the top. So if I want to bring it down to the bottom, I'd bring it down something like that. Now, I probably went a little too far, but it's a sketch. I just want to see it flipping over. Okay? And this little hump down here, I'm going to take and flip to this side. Okay, so I've taken care of the two humps, so to speak. Now I'm going to take care of this arm. This arm goes up. If I want to flip it over, I'm going to continue it right here and flip it over. I just took the arm from the top, flipped it to the bottom. This arm right here goes to the bottom. I'm going to take it and move it to the top. Did I plot any new points there? No, I just, in my mind, as best I could, I tried to flip the picture over the x-axis. Flip the humps, flip the humps. Flip basically the arms, flip the arm. Flip the arm, flip the arm. All right? Now, to write your function, your new function, I just want to put a negative in front of this entire, in front of that entire function. That's all I want to do. Yesterday, we actually sat there and distributed it out, correct? I'm going to show you a different way you can write it and leave it. We're going g of x, and it's equal to negative times f of x. So put a negative in front of all of your stuff. X to the third plus 5x squared minus 8x plus 1. That's it. That's all you got to do. Yesterday, we sat there and we made that negative go to everything, correct? But you don't have to. Okay, I'm not going to make you. And the reason for that is because you could put in your calculator, you could go graph these, you could put that in y1, and you could type this right here in y2, the negative parentheses x cubed plus 5x squared minus 8x plus 1. You could punch it in just like that, and it would flip it over like this red graph right here. So I'm going to let you leave it like that. You got me? So just write x-axis reflection, and then your new function. All right? Now, when we have the pluses and minuses, I want you to combine like terms if you can, like we did yesterday. But with these negatives, don't worry about trying to do the operation out. Got me? All right, let's look at 3b real quick. Because A, we kind of did yesterday. B, we did not. Now, before we do anything else, I'm going to, on my slide here, I'm going to write that function that's up there at the top. It's f of x equals, I'm going to look at Hadley's here, x to the third, thank you, plus 5x squared minus 8x plus 1. Okay, so that's just the function that we're dealing with, correct? Where's the negative this time? Inside, okay? So negatives inside, remember, inside's horizontal stuff, okay? Now, when you're talking about just a negative, though, this is making it flip, but it's still horizontal. Think about this. If you flip over the y-axis, which way have you flipped? Left or right, correct? Which is horizontal. So it's still kind of horizontal stuff. The negative on the outside was an x-axis reflection. We went up and down. That's kind of vertical stuff, correct? But the negative on the inside is going to be a y-axis reflection. Now, our y-axis is right here, going up and down. So everything from the right comes to the left. Everything from the left goes to the right. I really wish, here's what I wish we could do. You take a graph like this and imagine putting wet paint on this line right here. And then taking the two pieces of paper, folding them together and bringing them back. That would make the picture, wouldn't it? Okay? So, imagine that. Imagine I put wet paint on this and you folded right on the y-axis. Right? This hump right here is going to stick on this side, isn't it? Something maybe like that. Correct? This hump down here is going to stick on this side, something maybe like that, right? And if I did it like that, this arrow going down right here, it's going to stick on this side, isn't it? Going something like that. Right? And if I had that wet paint, this arrow right here is going to stick on this side. You get that visualization now? Imagine if there was wet paint on it and you folded it right there. Where's the stick? Where's it going to end up sticking at? Okay? They paint in my little girl's class all the time. She comes home with paint on herself. Can imagine what happens if I pulled the paint out in here. We'd be safe, wouldn't we? I wouldn't be. I'd have it all over myself. How many of you are in art? Anybody in here in art? Does that visual makes a little more sense than yesterday moving the stuff up and down. So with x-axis reflection, you can do the same thing. You can do the same thing, put the paint on your original and fold it this way. Where's it going to stick? Okay? So you guys look at example 4 real quick. Go to example 4. It should be the same two types. Oh, wait a minute. What did I not do on 3B? I didn't plug my stuff in, right? What do I have to plug in? Negative what? I got to plug in negative x. So, my new function, all I want to do, and look, this is all you have to write. It used to be just x in there, right? Now it's a negative x. Take every single one of these x's right here and plug in negative x. It used to say x to the third, plugged in negative x, made it third power. For every one of them. It used to say 5x squared, now it says 5 times negative x squared. Used to say minus 8x, now it says minus 8 times negative x. And then plus 1 at the end. That's your new rule. All we did was plug in negative x. And look, it's horizontal because it's flipping over the y-axis. It's inside because it's horizontal. So we put them all inside of a parentheses. Horizontal inside, vertical outside. Once you finish that, then you can go to example 4 real quick. Tell what's happening, what type of, they're both reflections. Tell me what type. Show me how you're going to write the new rule. And then over on your pictures here, reflect them. Okay? About 5 to 6 minutes on that. Hang on a second. All right, guys, so looking at 4. Looking at the first one, it should be just like 3a. The negative is outside. That is an x-axis reflection. When you write the new function, you should have a negative and then your original function in parentheses. Now I saw some of you, this is fine, you wrote negative x cubed plus 2x squared plus x minus 2. That's fine too. You just distributed the negative. Right? But that's the function you want. Those are the two things you want written down. And then it's all about making the picture change. All right? Since it's x-axis, Everything on the top's got to come to the bottom. Okay? Since it's x-axis, everything up top comes to the bottom. So put your wet paint on it. If I folded it in half across the x-axis here, if I folded it in half across this x-axis, where am I delete? All right. This hump right here would come down to the bottom. Okay? If I fold it over, that hump's coming to the bottom. This little hump is going up to the top. My bar right here, my arm here, comes up to the top. My arm here goes down to the bottom. X-axis reflection folds bottom to top. Hump on the top goes to hump on the bottom. Okay? Bottom to top, top to bottom. All right. Down here. Listen up, guys. Down here. That negative is inside. So now I have a y-axis reflection. And if I'm going to plug stuff in here, hey, listen up. If I'm plugging stuff in here, I'm going to put that negative x in for all my letters. So I would have negative x cubed minus 2 times negative x squared. Uh-oh. Yes, ma'am, you do. Because you're plugging in something other than x. You're plugging in negative x. Then you would have minus negative x. And then at the end you'd have, what is it at the end? Plus 2? Okay. Plus 2. And that would be your new formula or your new rule, and that's your transformation. Now, listen, a y-axis reflection, you fold the paper left to right. Now, here's the thing about this one. This stuff right here is going to continue to line up if you fold it this way. That's still going to line up. What's not going to line up is this little hump. It's going to come over to this side. So it's going to be about right in there. This bar that's on the right is going to come to the left. This bar on the left is going to come to the right and move down this way. That would be your y-axis reflection. Fold the paper. If there's paint, if there was paint on your original graph, where would it stick on the other side when you fold it? That's how you do reflections. Okay? All right, let's look at 5. Now, with number 5, you got to look back at your chart. Okay? On this one, we have a 1/2. Listen to this now. Listen to this now, please. Yes, listen up, please. We have a 1/2 on the outside of our f of x. Is it multiplied or is it added? It's multiplied. We know it's vertical because it's outside, right? All right? It's vertical because it's outside. And it's multiplied, so it can't be translation. So it's either got to be compression or stretch. All right, Corey, why you say compression? It's a fraction. Vertical because it's outside. Compression because it's a fraction. Now, listen. Listen, we have to write by a certain number. And that number is 1/2. It's a vertical compression by 1/2. It's being squeezed vertically by 1/2. Now, What does that mean? If I take these bars, am I stretching them up or pulling them out? I'm going to pull them out. Okay? Now, we're just going to sketch a graph. We're not going to draw a perfect one. Okay? You got me? So, this graph, it's going to be similar to this W shape, but my new one, should the bars be outside or inside of the black graph? Outside, because you're vertically compressing, you're pulling it out. I know that's not perfect, okay? And there might be some spots that overlap, which is fine, but the end result, the end bars have to go outside. I vertically compressed. Imagine me taking my hands, putting them on the two black bars, and pulling them down. If I pull them down, they would be wider, correct? So that would be a vertical compression, and it's by a factor of 1/2. Now, your new rule, this is kind of the same thing we did with the x-axis reflection a moment ago. Everything in this function is getting multiplied by 1/2. That's what this says, 1/2 on the outside. So, for g of x, I would go 1/2 times everything. And I'm okay with you leaving it like that. I multiplied my entire f function by 1/2. My entire f function, which is 2x squared minus, 2x to the 4th minus 6x squared plus 1, was multiplied by 1/2. That's my new rule. That's what it says to do, correct? It says 1/2 times f of x. 1/2 times f of x. And that gave us a vertical compression. It's vertical because it's outside. It's compression because it's a fraction. All right, look at the next one. Go ahead. It's a horizontal stretch. First of all, how do you know it's horizontal? Inside, okay. So 1/3 is on the inside, so we know it's horizontal. All right, Nakia, keep going. How do you know it's a stretch? Three's on the bottom. It's a fraction, correct? And remember, inside, how do we think? Insane. Insane. It is. But it was outside. Outside we think normal. Inside is insane, right? Yes. All right, so look, listen. 1/3 times x, it's multiplied. That's what makes it a stretch or compression. Since it's 1/3 inside, it's horizontal stretch because we think backwards. Now, we still got to think backwards. It's a horizontal stretch by what number? By 3. You do the reciprocal, so flip that fraction. You flip the fraction because you're inside insane, okay? Inside insane. Flip the fraction. So, horizontal stretch. Horizontal is this way, correct? So if you stretch this way, are our bars going to get wider or skinnier? Horizontal stretch. We're going to get skinny if we stretch horizontally. We're going to get wide. We're going to get short and fat, all right? So again, guys, listen. A horizontal stretch is similar to a vertical compression because your bars are getting wider, correct? So let's draw them out here really wide. It could be something like that. It's wider, correct? It's wider. Am I saying that's exactly it? No. You can put it in your calculator and figure out what it is, but that's not, we don't have to do that right now. Yes, ma'am. Horizontal stretches and compressions you flip because they're inside insane. Okay, you see the chart for them. All right, one of them say 1/2, and then it says stretch by 2 or something like that for horizontal. Let me see the chart. All right, horizontal, it says, the first one says 1/5, it says stretch by 5, right? And the other one says 3 and compresses by 1/3. It just flips whatever the number is because it's inside. All right, so what are we plugging in for all the x's? 1/3 what? 1/3 in x. We're plugging that value in, 1/3 x, in for all the x's because it's inside. Whatever's inside that parentheses is what gets plugged in for all the x's. All right? So, I'll borrow yours for a second. So on this one, we would write this. H of x equals, I see a 2, then there's an x to the 4th. Well, in that x, I'm going to put 1/3 x. And then I have minus 6x squared, so I'm going to put another 1/3 x and square it, and then plus 1. All I did was take whatever is in this parentheses and plug it in for the x's. And that's my new rule. Ask. Go ahead. No, it says x to the 4th.
Yeah, well then you added that.
No. You're plugging 1/3 times x in for the x's. You're plugging it in. Remember, if it's horizontal, you have to have parentheses, right? You have to have parentheses, something to plug it in for. All right, listen, we're going to skip example 6, okay? We're going to skip example 6. It's the same, too, as example 5. Now, I think, yeah, examples 7, 9, 10, 11, there's no number 8. Don't be hunting for number 8, okay? And skip. We'll skip 8, okay? We'll skip number 8. All right. All right. Listen up. Examples 7, 9, 10, 11 are asking you to write the new rule. It's going to give you an original function. It's going to give you a transformation, and it wants to see the new rule. And most of these have 2 items in them. Okay? So it can get a little hinky. Example 7, the original function is f of x equals 6x cubed minus 3. And our transformations are going to alter that function. Okay? So here's the transformation it wants. Compress vertically. Now when you see vertically, is that inside or outside? Outside. I know that that's outside. And compress, is that telling you multiply or add, subtract? Multiply. Compress tells me multiply. So I'm going to multiply on the outside the number 1/3. I'm going to multiply the outside by the number 1/3. Okay, that's like example 5 we just did, right? Did it have 1/2? It had 1/2 of f of x, right? Okay. And then I want to shift 2 units right. Now, right. Is that horizontal or vertical? Horizontal. So right, yes, but it means it's located where? Inside or outside? Inside. Horizontal is inside. So right means that we are inside. And remember, inside is what? Insane. So if inside's insane and you want to shift 2 units right, you're going to add or subtract, right? Which one? Subtract. To shift 2 units right, we have to subtract 2 inside. If we're subtracting 2, that means we have x minus 2 on the inside. So let's write this down. Everything that we're seeing right here. Multiply the outside by 1/3. Okay? So we're going to take the outside and multiply it by 1/3. 1/3 times f of something. The outside, though, is getting multiplied by 1/3, correct? And what did we say is going on the inside? Right, x minus 2, because we want to go 2 units right. X minus 2 on the inside would make us go right 2. Now we need to apply these items, the 1/3 multiplied by everything, and the x minus 2 inside to our original function. So I would think we might want to start with 1/3 outside, correct? What's the original function? 6x cubed minus 3. Now, notice I didn't do the right 2 yet, did I? The only thing I did was the 1/3, correct? I multiplied the outside of our original function by 1/3. Where am I going to stick the x minus 2? Where, not x3rd, but just the, where just the x is at. That x minus 2 is going to go where that x is at. Am I going to put it in parentheses, or am I going to leave it in the open? Parentheses, because it has to be inside. So I'd have 1/3. I'd have my 6. Instead of an x right there, I'm going to have my x minus 2 cubed minus 3. Close it up. You can put, really, you would need to put 1/3 f of x minus 2. I'm not going to make you write that, though, okay? You can leave it just like that. There's other ways to write it, but I don't care if you leave it like that. Let's make sure we got everything. Do we have our multiplying on the outside by 1/3? It's right there, isn't it? Do we have our x minus 2 on the inside? It's right there, isn't it? And we have the remnants of the original 6 times x to the 3rd minus 3. We still have the 6, the 3rd power, and the minus 3. There's the 6, the 3rd power, and the minus 3. Let's do another one. Oh, no. You can go back and watch this later. All right. So, on D2L. Yeah, Facebook. Hashtag everybody's sleepy. All right. Hashtag nap time, that's it. All right, look at this one. We got the same original equation, but we got new items. Reflects. Now, what little notation makes us reflect? What little symbol? The negative. So I know I got a reflection, so I got a negative somewhere across the y-axis. Somebody look back at the chart, see if that's inside or outside. Look back at the chart, see if it's inside or outside. Y-axis reflection's inside. Remember, the y-axis is like this, correct? So inside moves right and left, correct? So if you reflect over this axis, you go from right to left, left to right, horizontal. Horizontal's inside. Okay? Now, The next thing is shift. Now for shift, that's where you're adding and subtracting, correct? It's going 2 units where? Down. Is down inside or outside? Outside, because that's vertical. Outside. And it's going 2 units down. So what am I going to have to write on the outside? +2 or -2? -2 on the outside. So on the inside, I need a negative, basically a -x. And on the outside, I need a -2. So on the outside, I'm going to have -2. Inside, I have -x. So I'll have f of -x. And on the outside, I would subtract 2. Those are the 2 things I want to do to my original function. This tells me, hey, where you see x up here, plug in a -x. And at the very end, behind that -3, subtract 2 more. So let's put that in there. I got 6. Instead of x cubed, I'm going to plug in -x and cube it. Put my -3 there. And I also want to subtract this 2 from the end. Now, what did we do yesterday right here? We combine like terms, and we can still do that, right? That should be fairly straightforward, all right? -3 and -2 combine to make -5. Very good, George. So we'll have 6 times -x to the third -5. And we implemented those 2 transformations into our example. One more. One more. I won't do the last one, I promise. One more. All right. Yeah. So, look, our original function is, guys, listen, our original function has changed. I know, I was funny. All right. X cubed -2 is our new function. This time it wants us to compress, that means multiply, vertically, that means outside, by 1/2. So that means multiply 1/2 on the outside. So right now we ought to be thinking 1/2 f of something. And this one wants us to move the x-intercept. That's really not important. It says move it 3 units right. X -3, where at? Inside or outside? Inside. Right is horizontal. So x -3 on the inside. What that's telling us is multiply the whole thing by 1/2, put x -3 in parentheses where the x is. So, OS, outside. All right, so 1/2 goes outside. I still have 8. Instead of my x right here, I'm going to put my x -3, and I'm going to cube that, and then go -2. I put 1/2 on the outside. I left my 8. Instead of x, I put x -3. That makes me go right 3. I kept my cube. I kept my -2. I'm done. Okay? Tomorrow, we will practice with this. If you need some extra work with it tonight, watch the video. It will be on D2L. Okay? I know it.